These are going to be equations. So really, for the first time, there's going to be an equal sign in these. Up to this point, there really has not been an equal sign anywhere in these. And it's going to involve radicals. As you guys know, Chapter 8 is all about radicals of various shapes, sizes, and forms. So one important note here, I want you guys to understand this, and I think you'll see this illustrated at some point here today. When you're solving radical equations, it is entirely possible for you to do everything right. For you to do everything right, where you show all your steps and you don't make any silly arithmetic errors. Everything goes according to plan. You get to the very end, you get an answer, or maybe even you get a couple of answers, possibly. But when you check those answers or that answer, it turns out that that answer does not make the equation true. So, one of two things might have happened, right? If you check your answer and it doesn't make the original equation true, what are the two things, or at least what's one of the things that might have happened?
You messed up.
You messed up, right? That's possible, right? We all make mistakes. You might have messed up, but it's entirely possible for you to make no mistakes at all, get all the way through the end, get an answer, and find out that that answer doesn't work. Well, you'll see that illustrated here today. We call those answers, they're important enough they have a name. Those are called extraneous. Write this down. It's a big word. Extraneous solutions. So those are solutions that appear to be true at the start, right? As you progress through, they appear to be good solutions or a good solution, yet when you check them, you find out that they actually don't work. And we'll talk about why that is and what you do with that, but I just want to kind of let you guys know that ahead of time. With these equations that involve radicals, that's a thing. That's something that we want to make sure that we pay close attention to. Okay, so let's go back up to here where you see this little expression, the square root of a being squared. Any ideas on how that would simplify? What do you think, Alec? Yeah, it would just be a. Another way to put it would be this. Like, how does the squared and the square root interact? What do they do with each other?
They cancel each other.
They're inverses. They cancel each other out. So the square root and the squared would cancel each other out to just get an a. So let's do one example here together. We'll do a couple of others as well, and we'll head to the board and see how you guys are doing with this. Take a look at number 1. It says solve the square root of x equals 4. And so let's use kind of those old equation solving thoughts that we've talked about in the past. If we want to get the x by itself, of course solve means isolate the x. So if we want to really get the x by itself, we can see that it's not by itself. What's with it? A radical, specifically a square root. So according to what we just talked about, how do you get rid of a square root? That's right. So if I square this side, I'm going to be able to get rid of the square root, but according to all the rules that we've learned out, with equations before, they still apply. I cannot just square one side and call it good, right? Whatever I do to one side, I got to do to the other side, and so I'm going to square the other side also. So, did you guys look ahead? Did you already do this one? Did you get x is equal to 16? Okay, so this is going to seem a little weird, a little simplistic to do this, but there will be a point to this. I'm going to check my answer. I'm going to check it in the original equation. So I'm going to check over here. And I'm going to write square root of 16. Do you guys remember seeing this symbol before? Possibly equals, right? The question mark just means I don't know. It might equal. We'll see in a second. We'll confirm or deny that. So what is the square root of 16?
4.
Yeah. So you get to the end there and you say 4 equals 4. Yep, that's true. That means that x equals 16 really is a solution to my original equation. Like I said, that might seem overly simplistic right now, but wait, it'll become a little more important soon. Make sense? Okay, awesome. Let's take a look at our next one. We'll do 2 more, and we'll go to the board. So with the next one in your notes, number 2, there it is. I'll let you guys kind of help me out with this one as far as what we should do first. Notice that the radical is by itself, right? The radical is by itself on one side. There's a 7 on the other side. So what do you think we should do first? So square root. Square the radical. So I want to be clear. Do you want me to do this?
No.
Or something different?
Something different.
Okay. So something different would be?
Squaring?
Squaring. Yeah, let's square both sides. Effectively, Amelia, when you square both sides, what are you really trying to do when you square? Cancel out the radical. That's right. So when you cancel out the radical like you suggested, we get 4x plus 1 is equal to 49. Let me turn this over to you guys right now. Will you guys take this to the finish line and check it? Like I told you, it's very possible to do these. Feel like it's pretty easy, no issues at all. I did all the steps right. Get an answer that seems right, yet when you check it, it doesn't work. It's not a solution. So make sure you check it and make sure that you didn't get fooled by this question. You think you did it wrong?
I think I tried to take the one out too early.
You absolutely did take the one out too early. Sure. You bet. Yeah, so Jake had a real good point. He before he did any squaring, he started by subtracting the 1 from both sides, and it's definitely too early. You can't touch anything inside the radical until you actually deal with the radical and get rid of it. Once you get rid of the radical, then it's fair game. You can add, subtract, multiply, divide to get rid of those things, no problem. But before that, you definitely cannot do that. Christiana, how'd it go?
Yeah.
What would you do first?
I squared both sides, so I squared it. So that just takes out the square root, and then I squared the 7, so that's 49.
Okay.
And then you minus 1, that's 48, and then you divide by 4, and that's 12. So x equals 12.
Okay, so you divide by 4, x equals 12. So, seems right. Seems really good. Your steps are very clear. And you did check it?
Yeah.
And so this is not one of those ones where it's an extraneous solution. So your check would look like this. Let's make sure that she really did check it correctly. Did you just plug the 12 in for the x? That's really all you got to do. And then see what happens. So this possibly equals 7, not 49. This is an important point, actually. You might have just misspoken right there. But really important point, when you check these, you want to check these in the most original, right? The very, very first equation that you saw, you want to check them in there, not like a second or third step. Make sense? Okay. So, yeah, 4 times 12 is 48. And 48 plus 1 is 49. And 49, square root of 49 is 7. So it does check. So I think I agree with you that x equals 12 is a solution. Okay. You guys still doing okay? Okay. Any questions at all? All right. So number 3, a little tougher. Let me turn you loose on that one for a couple of minutes. I'll let you work together, work it through, see what you come up with. I'll give you the solution here in just a second. And supposing that we're all doing pretty good, we'll head to the board after that. The radical, and the other side too. Okay, I like it. So the point is, why would we square the radical? Get rid of it. Yeah. Okay, so that would give us x squared plus 9x minus 45. Over here we get x squared. And as I walked around, I kind of peeked over shoulders. This was kind of the step where I saw some folks pause a little bit. And it's like, all right, what do I do? Avery, did you come up with a good idea about what to do with that step?
Yeah.
What'd you do?
Minus x squared by x, like I minus x squared.
Say it one more time.
I minus x squared and x squared.
Yeah, from both sides?
Yeah.
Yeah. Why did you do that?
Because they're like terms.
Yes, exactly. So if you see like terms, whether they're on the same side or opposite sides, you want to try to get those together. What comes out of this is always something that I feel like makes us uncomfortable a little bit. Did you guys write 0 equals? Mm-hmm. I feel like sometimes having a 0 on one side almost makes it feel like we did something wrong. That's definitely not the case. We did something right for sure. So 0 equals 9x minus 45. And then for you guys, this is a pretty quick and easy solve. Did you guys get x equals 5?
Yeah.
Okay. Now, did you check? This one was the most complicated one yet. Did you check your answer?
Yeah.
Did it work, Alec? It did. It did. I'm not going to, I won't put the check up there because we've already done 2 examples of checks. Actually, I take that back. I'm going to put it up there. I want to give you guys a good example. You should always do this. So 5 equals square root of 5 squared plus 9 times 5 minus 45. When you do the arithmetic, you end up with 5 is equal to the square root of 25. And so you get 5 is equal to 5, and it does check, just like you said. So anyway, there's that. You guys have any questions before we go to the board? Fantastic. All right, well, let's go ahead and go to the board. No, you do have a question. Go ahead.
What would you, so if like the answer doesn't check out, what would you put as an answer? Just like no solution or?
So if you got one answer, if you got like 5, let's say,
Yeah.
and it did not work, and you like go back through and you double check everything, you're like, yep, I did everything right, and it definitely doesn't work, you would say no solution.
Okay.
All right, good deal. Hey, let's go to the board real quick. Let's see how you're doing with this. There we go. Okay, so number 4 says solve. Check it out. Square root of x minus 10 plus 6 equals 2. So this is just like the one we finished with a second ago as far as the concept goes. Before you decide to square anything on both sides or get rid of any radicals, you need to get the radical by itself. And so what would you guys do first? Subtract 6, yeah. So subtracting 6 is going to give us, come on, there we go. Subtracting 6 will give us square root of x minus 10 is equal to negative 4. So this is actually going to be one of those ones that's a no solution because you can't have a principal square root equal a negative number. But let's take it all the way through to the end. Here's what you might do, because I want to pretend like you're doing a quiz or a test. You might not notice that step. If you didn't, what you would probably do now is you'd square both sides. So when you square both sides, x minus 10 is equal to 16. And then you would add 10 to both sides and get x equals 26. And if you didn't check it, you would be wrong, because this one is going to be a no solution. When you check this, you get the square root of 26 minus 10 plus 6 might equal 2. Well, so 16, right? I'm sorry, Ellie, question.
This is correct.
You were what?
Well, if on a quiz, if we did notice that the square root equaled the negative, would we be able
Like,
to
could you stop right there? Let me talk about that in a second. That's a good question. Okay, so you'd get square root of 16 plus 6 might equal 2. 4 plus 6, oh gosh, now you can see that that doesn't equal 2, right? 4 plus 6 is 10. And so that means that 26 is not a solution, meaning that it's no solution. So let me talk about one thing here, and then I'll address Ellie's question as far as how this would be graded. Can we get to the heart of why, guys, can we get to the heart of what the issue is here with the no solution versus solution? Let's look at this step. Isn't it this step again right here, where you got root x minus 10 equals negative 4?
Yes.
Notice the very next thing we do is we square both sides. What does squaring do that might lead us down this false trail that we got led down here?
It changes a negative to a positive.
Yeah, remember, anything squared is a positive. So whether it's positive 4 being squared or negative 4 being squared, you're going to get positive 16. And so that's where you kind of get led down this false trail where it's like everything is going well. Oh, wait a minute, that answer didn't work. That's kind of the step where you get led astray. So Ellie, your question. If you were doing, let's say this was a quiz question, because I think your question is valid here. And let's say you're doing this and you're having a good day and you get to this step right here and you think to yourself, oh my gosh, I think this is going to be one of those no solutions. I recognize it. You want to get to the point where the radical is by itself. It's very possible to get fooled early on, right? So if you don't get the radical by itself, like even this type of good thinking you could be led astray for sure. But if you get to this point, you're like, hey, I recognize this is going to be one of those no solutions, and you want to kind of take the risk and just stop right there, I'm going to need an explanation from you. So if you wanted to write, maybe you omitted all these other steps, all these things in the box simply weren't there, and you wanted to say something like, hey, there's going to be no solution for x. My reasoning is you can't have the square root of x minus 10 equaling a negative number. I'll take that kind of reasoning. But be very cautious, right? Because if you leave anything over on there on that side with the radical, you could be led astray and your reasoning could be bad.
Yeah.
So the safest way is to continue on all the way through and check. That's the safest way to do it. But if you're pressed for time or for whatever reason you just want to do it that way, if you give good reasoning, I'm fine with that. Yeah. Okay, let's do one more. Number 5. And then we'll call it a day at least with your notes. So let me give myself a little more room here. There we go. So number 5 says square root of x minus 2 minus x equals negative 4. This is where things will get a little more interesting for us. Maybe a little more your speed. So remember from number 4, before you square both sides, you've got to get the radical by itself. What would I need to do?
Add x.
You are correct. So add x to both sides. So this gives us a somewhat unique expression, at least compared to what we've been doing. You're going to get square root of x minus 2 is equal to positive x minus 4. So now the radical is by itself, and this would be maybe where you'd be tempted. I mean, I don't know if Ellie would say this or not, but somebody who was thinking, like on that last one, somebody could easily look at this and say, hey, look, there's a negative 4, therefore there's no solution. This would be a bad time to apply that kind of reasoning because it's not just a negative 4 over there, there's also an x. And so that right side would also depend on x, not just the negative 4. In any case, if we're going to continue on with this, how do we get rid of the radical? We don't square root. We square both sides. Yeah, so we're going to square the left side, and then we also have to square the right side. The left side ends up going pretty simply, I hope. Rocky, when you do square that left side, what comes out of that?
X minus 2
So I'm glad we're talking about this when we got some things to talk about. So x minus 2, I agree.
equals.
The right side, now the right side, I'm peeking over your shoulder. We got some things to talk about on the right side. X minus 4, quantity squared. What do we have to do? We have to FOIL it. That's right. We have to FOIL it. If you were tempted to just write, hey, x squared is x squared and 4 squared is 16, remember when you have the square of a binomial, you need to expand it and then FOIL it. Nice work. So, looks like this, x minus 4 times x minus 4. Rocky, do you see it? Rocky?
Yeah.
Okay, question, Jake.
Okay, I'm a little bit confused.
Where are you
So
confused?
I did the, instead of doing x minus 4 squared, I did minus 4 plus x for some reason.
Believe it or not, that'll work out just fine. If you FOIL correctly and I FOIL correctly, we should get the same thing.
Okay.
Yep, let's check it out. If you've already done that, have you FOIL? Let's see how this works out. So the left side is x minus 2. The right side would be x squared minus 8x plus 16 when you add your two middle terms. Did you get the same thing, Jake?
Yeah.
Because minus x times minus x would be positive x squared. So fair question, it should work out just fine. Okay, another big question for you. What kind of an equation do you guys see up there?
Trinomial minus pi.
It's a trinomial, and it's like, it's got x squared. Remember the word we use for this? It starts with the letter Q? Quadratic. So what is our standard form of a quadratic? It's ax squared plus bx plus c equals? 0. So what should I do to get it to that?
No. Zero factor property?
We'll use that zero factor property, but before we can do that, don't I have to have equals 0? So how do I get there?
You have to move the other terms to the other side.
Yeah, combine some like terms. So if I subtract x and add 2 with both sides, I end up with 0, which is what I wanted, equals x squared minus 9x plus 18. So this is taking you back to last chapter, or two chapters ago. What do I need to do to use that zero factor
Do you need to do
property?
the X thing?
Yeah, the magic X thing, right? Hunter, stop your whining. It's wearing me out, buddy. Okay, so what number goes in the top of the X?
9. Negative 9.
No, we usually did 18.
Oh, whoops.
You usually put your AC in the top. What goes in the bottom? Negative 9, that's your B. All right, now we're trying to think of which numbers multiply to be 18. Say again? You got it. Yep, so negative 6 and negative 3. So this would factor as 0 equals x minus 6, x minus 3. Man, what a great connection from 2 chapters ago. I love it.
It's a beautiful thing.
It is. It's a beautiful thing. Okay, once you have it factored, what comes next? Oh, if you FOIL it, aren't you just going to end up with what we had 2 steps ago?
No, you add them to 0. Or you put them in proportion to 0.
Yeah, okay, I'll take that. You set them equal to 0.
And then you get x is 6 and x is 3.
I agree.
6
So here's the challenge. Guys, we got about 2 minutes. The challenge is this. Do both of those answers work? Does one of them work? Or do neither of them work? How do you know?
You gotta check.
You got to check them. So let's check them. If I try out the 6, I'm going to get square root of x minus 2 minus 6 equals negative 4. What's 6 minus 2?
4. So 2
6 minus 2 is 4. 6 minus 2 is 4. Square root of 4 minus 6.
That is it.
Hold on. I don't know what you mean by that is it.
That's the answer.
I will say,
Negative 6 is the answer.
hey, little miss, pack up early. Stop. Why don't you unpack? We'll wait. I'm waiting.
Oh, sorry.
If you promise not to pack up early, I won't take attendance early. Promise. Okay, so x equals 6 works. Does 3 work, though? You say no? Let's find out. Christiana, why don't you write this down with me? Unless you already did. Square root of 3 minus 2 minus 3 equals negative 4. That's just 1 minus 3 equals negative. Whoa, that didn't work at all, does it? That's negative 2.
X equals 6 is the answer.
So x equals 3 is one of those extraneous solutions. X equals 6 is actually an answer. So, hey, does that question right there, does that feel like something we ought to practice a lot?
Yes.
We'll be doing that when I see you on Thursday. Yes, Thursday. Have a great day. See ya.